Hello everyone and welcome back to While True Learn. Let's do some more work today. Something exciting I'm sure will happen today. What's CB? Random forest, a more complex structure than a decision tree, but it can recognize more classes. Oh, that's really cool. So I can buy more things that will make things better as an even algorithms. Hardware, increase sockets processing queue size by 5. GPT 250 increases nodes work speed by 5%. Interesting, very interesting. Cat skins. Fair enough. Okay, so let's go in here. So I want to check out the startup because that's kind of like background money making without actually doing anything, right? We are trying to launch our self-driving taxi service. It is a very promising startup, but we have a problem. Our algorithm makes a lot of errors when it tries to recognize traffic light signals. In result, the car sometimes moves on stop signal. That sounds very dangerous. We need you to solve this problem. The code must be working very fast. Okay, join the startup. So we want to recognize red and green. Okay, so and we want circles. So we should, what should we do? Should we sift out the circles first? Yeah, let's try doing that first. So circles first. And we'll probably, seems that we will have to separate it out as well, so do it in parallel. Can I? Okay, I've got red very fast somewhere actually, only red fast. I will take that. Oh no, that won't work because I want the greens as well. Okay, without blue. Okay, so sift the circles without blue, and I don't want that. I don't want next. Oh yeah, I want the decision tree. So sift without blue, decision tree color. We want red and green. Red, green. Test run. Oh wait, stop. I want to trash can some of these things, so trash that. Actually, that's all. Okay, I think that is the slowest bit of our network right now, and that is the fastest. Well, this is not overfeeding us right now. Okay, stop. Our users per day is only 16. Can I change the users per day? Oh wait, let me put that there. Let me move these things out of the way. And because the sifting is the most intensive thing happening right now, it takes the most amount of time. But if I can use 2 sifters, and I just join this right back to the other place. Let's try that. So we can handle 20 users per day. Okay, so that's showing us how many users we can handle per day. We still don't know how many users we're going to have. So that's 35, 36, 38, 40, 41. Oh, maybe about 40 users per day. I mean, this one is still not getting built up. So the sifting is definitely what our bottleneck is right now. I wonder if I should try adding another set. Not sure how many users per day it will have. Actually, you know what? Let's release it, because we should check. Oh, current users is 86. Is that per day? Yeah, I think that is per day. Yeah, that's not going to be enough because we can only do 40. So we need another one of these. Not another one, we need another 2 of those. Plonk it there. And then we need, so these 2 sift will go there. 1, 2. We need 2 more sifters. 1, 2, like so. And we'll link all of these back up there and trash these. Let's try that now. Okay. Still the sifters that are slow. Can I reverse this? Yeah, I don't think this is the most efficient way of doing this. Okay, can I delete these? Yeah. So I can't put that first. What if I put this first? Without blue in progress. Okay, so without blue, filter that out first. Filter out the red and green. Maybe put the sift there. How efficient would that be? Okay, the sifter still gets blocked out, but yeah, because that's getting rid of the ones we don't need. We definitely need the red and the green. So regardless of where we put the sifter, we will have to process it. Okay, let me get rid of this and that and that. Let's go directly there and test run. Let's see how many it can do. Okay, that's clearly not going to be enough. Well, because we need this to speed it up. So maybe I will have without blue 2 there, there, and we need another sifter. I wonder if I will need another one of these over here so we can have 4 sifters. That's still pretty good. This is potentially quicker than the other one, but I can't tell. So let's say that's 25. So I'm just waiting to see users per day, how much it'll go up. Okay, 47, 48, 49. Will it do as many as 80? And adding a little bit of spare capacity, 100. No, I think, oh no, maybe. Struggling to do 60. Yeah, struggling to do 60. So, wish there was a bit more space. Move that over there. Move that over there. Okay, we'll have 4 sifters. Put that there. Put that there. Connect that up like so. And put another couple of sifters here. And put that there. Okay, so those cost money, so they are something that we have to be careful about using. All right, let's see. But it said that it was 80 users, and I'm hoping that means 80 users per day. And this should take us up to near enough 80 users per day. Yep, easily 60. Yeah, I think this will do. It's very expensive, so I hope we get 80 users per day and that the 80 users per day make us a lot of money. Stop, release, accept. Okay. I wonder if I needed to spend that much effort on it, but let's see. Oh wait, I forgot to read it. What does that say? We have dozens of scientific equipment in protected areas made to look over the objects of national heritage. We receive info from our equipment on a daily basis and need to sort it depending on the color of the report. We need to make it work better and react faster. Can you make a program that will help us? Let's see. Okay. That seems straightforward enough. Only red fast. No, that won't help us, right? We need decision tree. We shouldn't need a trash can. So red and green. So that'll be red and blue and green and blue. So green, blue, and red, blue. So red goes there, blue goes there, green goes there, blue goes there, and that's the input. Test run. Okay. Average net overload. Huh, I wonder what that is. Okay, release. Next project. Making a lot of money. Forecasting the amount of sales in the clothing store. I have a clothing store and want to know how much money I may get during holiday sales. Okay. Wait, isn't this the same as before? So, wait. Custom nodes. 4 parallel. Only I don't understand any of these. Oh, RGB sort, red, green, blue. Yeah, so don't I just need to use that? Red, green, blue. You ran out of time. Okay, I suspected as much, but let's put another RGB sort there and do the same thing. Red, green, blue, parallel, parallel, input, test run. There we go. Shablam. Easy peasy lemon squeezy. Next project. We are a scientific laboratory that researches human behavior. We need to extract the data of our last research from our equipment across the city. This is some very important information, so please be very accurate. Okay, so you just want red and green. Okay, so if you want red and green, oh, there is a way. I have something. Oh wait, I have RGB sort, so I could just use that. Oops. Red, green, and oh, okay. Fine. Release. Oh, we have another startup. Yeah, Amazon. Okay. What does this entail? Good day to you. My name is Jeff. Jeff Bezos. I'm sure that's meant to be. I own a small online bookstore. I need your help in choosing the logistic company depending on the buyer's region and type of the book ordered. I would love to automatize the process with the help of a special program, but I'm not experienced in this sort of things. I offer your share of sales done with the help of your system. Please note that all data must be processed. I'll take it. Oh, this is complicated, huh? Red, green, blue. Hold on. Wouldn't it make sense to just split it to those three and ignore those two? Oh, no, because we need red triangles here. Red triangles can't go there. And we want green squares here. Huh. Do we have enough space for this? Okay, so we care about red. Okay, so red, the three reds, let's do that first. So I'm tempted to use an expert system. Wait, is there anything else here we can use? No. Just so that I don't have to worry about it too much, and then we can make it faster later if necessary. So red and a sift the triangle out, because the triangle needs to go there and everything else needs to go there. Oh wait, sorry, red else needs to go somewhere else. So we can do the same thing with green, but I think we can just use a decision tree now because all the red has been taken care of. So this can be green, green, we will sift out the triangle because the triangle needs to go there and the square and the circle needs to go there, and the blue, all the blues just go there. Test run. Yeah. Oh, that can easily handle 70 users per day. 80. Yeah, that's not too bad. Wonder how many users we're going to get. It's over 100, or let's say 100. Stop. Release. Accept. Holy crap. The self-driving cars is 568 current users. Why is the weekly income negative $1,178? Holy crap, the current users there is 654. Okay, I need to patch that. We need to handle more users at less cost. Wait a minute, or is that just, yeah, that is definitely overloaded 18%. That's 568. Ooh, private. Mail from friend. Hey, what's up, buddy? How are you? Listen, I remember that you could not pay you a long time, and I'm very grateful to you that you did not demand it for so long, but to be in debt even to a friend is not cool, right? Therefore, take this money. I return everything that I owe to you. Thank you, friend. You really helped me out. Yeah, and how about we go to a concert next week? Cash. I'll take it. Okay, so let's patch this thing. So how can we reduce the cost of this? Wait a minute. Oh no, because it's a sift that's taking up all that time. Once we've gotten rid of the blue, we want to get rid of the squares and the triangles. I mean, even without blue is a bit slow. I mean, if we sift it first, that's definitely going to be more expensive because it has to sift things that we really don't need, because we don't need to sift through the blue ones. So we cut down all of the inputs to 66.67 or 66 recurring percent to just these 6, and the sift takes a long time. Okay, maybe what I need is to go there. A more complex structure than a decision tree, but can recognize more classes. So but that takes 1.4 seconds, so that's not going to help us. Hardware increases nodes work speed by 5%. Increases sockets processing queue size by 5. Even if we had a bigger queue, would that help? Because that's not the problem. It's the processing of these circles that's the problem. Because I could, that's 1 second. I could put 2 of these there. So blue, red, and green, and 2 more there. Red, blue, red, and green, blue, oh actually let's try that. That'll be even faster. Okay, I need a trash can for the blue test run. Okay, the sifters are definitely not getting overloaded. Oh well, they are a little bit. Oh wait, we don't need that anymore. Although that's a different issue. So we're sending the reds there. So I could actually get rid of that and just connect that there. And the greens there. Gets rid of 1 node. Okay, let's put 1 more there because that seems to be struggling. And let's connect these back up to these guys. I think the server cost is still the same here, but can it handle more users? Let's wait and see. You can see that the sifters are now getting blocked up again. But what we could do actually is we could get rid of these 2 servers because that's putting a lot of cost on us and they might not be providing us any real benefit. So I'm just going to connect these 2 up manually and let's try that. It looks like I was over optimizing possibly. That is still, actually is it? What if, stop that, I take that off and I only use 1 of these because these are faster than the other ones. How many are we processing now? Okay, this one is definitely an issue. both of these. Okay. Even if we're cutting the server cost by a little bit, let's check this. So that's $4 per second. How does that work? So that definitely means that this bit is getting completely processed. Okay, so I'll plonk another one down and try that again. We're saving like $4 per second right now, but let's see how many users this one can handle. Yeah, okay, so these sifters are definitely not getting overloaded now, but how many users can we handle? Come on, is it just 90? Okay, so this decision tree bit is starting to get a little bit overloaded now. I don't want to use another server. Can I improve this somehow? Decision tree color, okay. Instead of using, yeah, the good thing about this is that we are doing these two in parallel. Can we parallelize that more? What if we didn't use servers? Huh. Can we? That's pause. So we've already split this to red and green. Wait. What if instead of using that, I use another decision tree color? I just do any. It's just a way of splitting it. Yeah, because that is quicker. And I don't need to pay server cost. The only problem is they're not properly split. But that's okay. Okay, let me do that. Let me just spread this out a bit. I'll get rid of that. So I'll put another decision tree, any and any, and I'll send them over to there. Because we want as many of these processing in parallel as possible. The server cost is really low now, it's only $2 per second. Okay, I can see that some of it is getting overloaded a little bit, but that's okay. It kind of balances itself over time. What I need to do now is split that apart a wee bit more. So I will do this, I will do this. Yeah, okay, so I will use a server, send this there, send that there. I will have another decision tree here, and that will also be red, green, and I will do exactly the same thing. So we can process twice as many, probably. For a fraction of the cost. Let's see, so this is the ones getting overloaded now, which is fine. And the sifters are overloaded as well. Now how many can this handle? Let's wait and see, and once we know that, we'll call the episode there. When it was 90 before, this should have increased it when our sifters are fully backed up. Yep, definitely going above 90, 100. $118. So we got another 20, was it 90, another 30. Yeah, we'll take it, but a fraction of the cost. Okay, we'll call the episode there. Thanks very much for watching, and see you next time.